Okay, so there were two on this sheet that we didn't get to in class, number 4 and number 5, and I promised I would do their solutions here. So first, number 4. A jogger with a constant velocity of 5 meters per second and with an iPad on again runs by a stationary dog. So our two parts are the jogger and the dog. Okay? Constant velocity for the jogger, VF, 5 meters per second. Runs by a stationary dog, VI, 0 meters per second. After a second passes, the dog decides to chase the jogger and accelerates at 1.5 meters per second squared. So the dog's acceleration, 1.5 meters per second squared. The jogger wearing an iPod doesn't hear the dog and doesn't change her speed. How long before the dog catches up with the jogger? Okay, so the time for the jogger, we don't know. And the time for the dog, we don't know. But we know that there are 1 second difference. So you could either call the time for the jogger delta t of the dog plus 1 second, or you don't want to do both of these, or you call the time for the dog delta t of the jogger minus 1 second. This is true of the other questions that we did in class too, but the reason I'm saying it here is because when we get to sub in for the time, it's going to be clear that one way will be easier than the other. Okay, so if we stop and think about it, we have our jogger running along. We have our dog who decides that they're going to chase the jogger. And so the jogger passes the dog goes after. The delta D's should be the same. Okay, we don't know what they are, but they're the same. So we don't know the delta T's of either of them, and we don't know the delta D's, but we know they're the same. So 2 unknowns for the jogger, 2 unknowns for the dog. That means that we're going to have 3 equations, because the delta D's are the same for the jogger and dog, and the times are both different. So 3 unknowns. So whenever we have 2 unknowns under the same thing, and that we're going to need a system of equations, we always try to get the delta D's for the 2 objects. So this delta D for the jogger is just going to be V av delta T, jogger. And this delta D for the dog is going to be VI delta T plus 1/2 A delta T dog squared. This is going to go to 0. So delta D of the dog will equal 1/2 A delta T of the dog squared. We can't find either because we don't know the delta D or the delta T, the delta D or the delta T. Okay, so it's like a system of 2 equations with 2 unknowns. What we do know is delta D of the jogger equals delta D of the dog. So where the jogger's delta D is, we can sub in V av delta T of the jogger. And where the dog's delta D is, we can sub in 1/2 A delta D of the dog squared. Now the problem is we still have so we've gotten rid of the delta D's, but we still don't know either of the T's, and they're not the same. So this is when we go back up here and we look at our 2 possible equations for delta T. Obviously you don't want to sub them both in because that's just going to defeat the purpose. But which one will it be easier to try to keep? Well, if you subbed in for delta D of the dog, you'd have to square it. So I would sub in for delta T of the jogger. So I would write it as V av brackets delta T of the dog minus 1 second is equal to 1/2 A delta T of the dog squared. Right? I could have kept the jogger's time and subbed in for the delta T of the dog, but then I would have to multiply the brackets by each other. So going this route will be easier. In the end, you'd end up with the same answer. Okay? And again, the jogger's time is a second less than the dog's. Excuse me. The jogger's time, I don't know, I lost the 1 plus there when I brought it down. thing, and I went to explain it, and it's like, that's not true. The jogger's time is 1 second more than the dog's because the dog started a second later. So if the jogger runs by, the dog leaves a second later, the dog catches up to the jogger in 5 seconds, then it means the jogger's been going 6, 5 plus 1. All right, now that we have this, we can multiply through. So V av delta t of the dog plus V av times 1 second is equal to 1/2 a delta t of the dog squared. Now I'm sure a lot of you would like to just drop this 1 second, but remember the unit is important. And so yes, 1 times V av is just going to be whatever V av is, but that second's going to change your units into meters from meters per second. It's going to be a quadratic. T term, whole number term, t squared term. So you want to rearrange it in the form of ax squared plus bx plus c equals 0. And when you do this, you should always try to keep your 1/2 your x squared term, your t squared term positive. So bring the other two over. So that'll end up being 0 equals 1/2 a delta t of the dog squared minus v av delta t of the dog minus v av times 1 second. And now fill in your numbers. 1/2, the acceleration was 1.5 meters per second squared, delta t of the dog squared, minus the runner was going 5 meters per second, so minus 5 meters per second, delta t minus 5 meters per second times 1 second equals 0. Half of 1.5 is 0.75 delta t of the dog squared minus 5 meters per second delta t of the dog minus 5 meters. Okay, and so now it looks like ax squared plus bx plus c, where a is going to be 0.5 meters per second squared, 0.75 meters per second squared. B is going to be negative 5 meters per second, and C is going to be negative 5 meters. 0. Okay, and the quadratic is x is equal to negative b plus or minus square root b squared minus 4ac, all divided by 2a. So delta t of the dog is equal to negative b, so negative 5, which is positive 5, plus or minus square root negative 5 meters per second squared minus 4 times a, 0.75 meters per second squared, c, negative 5 meters, all divided by 2a, 2 times 0.75 meters per second squared. Okay, so now we do our math. And we'll have 5 meters per second plus or minus. Negative 5 squared is 25 meters squared per second squared. 4 times 0.75 is the same as 2 times 1.5, so it's 3. Times 5 is 15, minus a minus is a plus. Meters squared per second squared. And on the bottom, 1.5 meters per second squared. So delta t of the dog will equal 5 meters per second plus or minus, this is going to be root 40 under here, meters squared per second squared over 1.5 meters per second squared. So we're going to get two answers. Delta t is either going to be 5 meters per second plus, and the root of 40 is 6.324 meters per second, divided by 1.5 meters per second squared. And when you do this one, you get 7.5497 seconds. Or the other possibility is delta t is equal to 5 meters per second minus the 6.34 meters, there's a 2 in there, divided by 1.5, but clearly this one's going to give you a negative. So it can't be this one. It'll be this above one. And so the question wants to know how long. So this is the answer to how long. And then the second part wants to know how far has the jogger run. So now you take this time and fill it in